We're going to talk about mole and how it relates to molar mass, and then do some conversions involving mole concept in this video. So let's connect mole to molar mass first. And you should be aware that molar mass can also be referred by other terms like molecular weight, molecular mass, formula mass, or formula weight. They all mean the same thing. So in the last video that I uploaded, you understood what a mole is. Let's recall a mole is that many things, and this number has a special name. We call this Avogadro number. So a mole of things would be Avogadro number of things, just like dozen things would be 12 things. This is a number. And it's good to, when you do problems, use the Avogadro number up to 3 decimal places. So its value is 6.022 times 10 to the 23. Okay, now what is molar mass? Molar mass is the mass of a mole of things. So you can say this is the mass of 1 mole of things, how much they weigh. That's what we mean by molar mass. Let's say you have carbon atoms. How do we get the weight of or the mass of a mole or that many carbon atoms? Let's think about it. Let's start with what we know about carbon's mass. We know that if you have 1 carbon atom, that's going to be real tiny. Okay, imagine a very tiny, just 1 carbon atom. Its mass is going to be 12.01. We said in previous videos that this is the average mass of carbon. So we can say 1 carbon would weigh 12.01 atomic mass units. These units are very small units. So that weight is a very tiny weight. Now, if you have a mole of carbon atoms, that means a group of Avogadro number of carbon atoms. So we can find the weight by just multiplying this number by Avogadro number. So 1 carbon weighs that much. If you have that many carbons, then the weight would be that number times 12.01. So it's going to be Avogadro number times 12.01 AMU. We can convert AMU to grams, and let's see what this number turns out to be in grams. In previous videos, I introduced what an AMU is. So if we use the definition of AMU, 1 AMU is 1.66 times 10 to the negative 24 grams. Now, AMU cancels out. You can put that in your calculator. You can see that these two numbers are inverses of each other. If you multiply this with this number, you just get 1. And 12.01 times 1 is going to give you 12.01, and the unit you have now is grams. Okay, you can check for yourself. Put this in your calculator and check. You should get 12.01 grams. You can see some interesting pattern here. If you have 1 carbon atom, the weight of that will be 12.01, this number, and the unit is AMU. But if you have 1 mole of carbon atoms, that means that many carbon atoms, a huge number. I can't really draw that many dots. If I just draw 1 dot per second, it's going to take me a billion years to draw those dots. So it's a huge number. So if you have that many carbon atoms, the weight of that will be the same number, 12.01, but it's in grams. Okay, so this is the molar mass of carbon. Okay, so we can say molar mass of carbon is 12.01 grams per mole. So this is the weight per mole. So the units of molar mass are grams per mole. Okay, so we can go ahead and fill this information here. So if you have 1 mole of carbon atoms, that means if you have that many carbon atoms, the weight of that will be 12.01 grams. Okay, so you could either write 12.01 grams per mole, or if you split it out like this, you can say 1 mole equal to 12.01 grams. It means the same thing. Okay, so guess what by the way, this 12.01 grams, it's a laboratory size sample, okay? And that sample contains a huge number, Avogadro number of carbon atoms. Because atoms are so small, there are humongous amount of things, and you need that many things to bring it into a laboratory size sample. Now, what would be the molar mass of copper? So 1 mole of copper, meaning that many copper atoms, the weight of that would be, go to the periodic table and locate the average mass of copper, 63.55. So it's going to be 63.55 grams. That's the molar mass, 63.55 grams per mole. Okay, so we can keep going. What would be the molar mass of water? That means that many water molecules. How do we find this now? Okay, let's simplify the problem by first thinking about a dozen instead of a mole. So let's say you have dozen water molecules. Here I have drawn for you a dozen water molecules. Okay, we can say a dozen water molecules contain 1 dozen oxygens. If you count, you should see 1 dozen oxygens and 2 dozens of hydrogens, because there are 2 hydrogens in each. There are 2 dozens of hydrogen in 1 dozen water, right? So let me write that down. So if you have 1 dozen water, you have 2 dozen hydrogens, and you have 1 dozen oxygens. Okay, you can scale this for a mole. You can say if you have a mole of water, so if you go ahead and draw a mole of these, imagine, then you would have 2 moles of hydrogen and 1 mole of oxygen. Because there are 2 hydrogens in each water molecule, you'll have twice as many hydrogen atoms. Okay, for 1 mole, there'll be 2 moles of hydrogen. So how do we find the weight of 2 moles of hydrogen? We know that each mole of hydrogen weighs 1.01 grams. So if you have 2 moles, the weight of that will be 2 times 1.01 grams. So all we are doing here is really multiplying hydrogen's molar mass by 2, because you have 2 hydrogens here. Okay, and then 1 mole of oxygen, that's nothing but the molar mass of oxygen, is going to be 16 grams. So 1 times 16 grams. Okay, so now you just have to add them up, okay? Because you have this much oxygen, this much hydrogen, and this much oxygen in 1 mole of water. You add them up to get the weight of the total 1 mole of water. So that's going to give me 18.02 grams. So the molar mass of water is 18.02 grams per mole. So we can put that information here. We can expand it out as 1 mole of water equal to that many waters equal to 18.02 grams. So from now on, you don't have to split it out like this. Just remember how we got the 18.02 grams. You just do 2 times hydrogen's weight on the periodic table and 1 times oxygen's weight on the periodic table, and the units for molar mass will be grams per mole. So let's practice one more example for molar mass. So if you have 1 mole of sugar, so this is the formula for sugar. That means that many sugar molecules. So how do we calculate the weight of that? So you do 12 times carbon's weight on the periodic table and add 22 hydrogen, so 22 times this number for hydrogen. And then you add 11 times oxygen's weight on the periodic table. You add them up, you get 342.34. Guess what the units will be if you're talking about molar mass? Okay, guessed it right. It has to be grams per mole. So we can say 1 mole of sugar weighs 342.34 grams. Okay, so notice that 342.34 grams, that's about 1/2 cup of sugar. Okay, so if you take 1 2/3 cups of sugar, if you take exactly 342.34 grams, which is roughly that, okay, and if you take 63.55 grams of copper, 18 grams of water, 18 grams of water will be 18 milliliters, because the density of water is 1 gram per mil. So 18 milliliters is roughly 3 tablespoons. So if you take 3 tablespoons of water, they all contain 1 mole of that substance, okay, which is that many molecules or atoms of that substance. Okay, so you have different amounts, but they all contain here, these all contain, you have exactly 1 mole of each substance. You have Avogadro number of water molecules here, you have Avogadro number of sugar molecules here. And if this is 1 mole, guess what its weight would be? This is 1 mole of mercury. So you have to go down to the periodic table and get the weight of mercury, which is 200.59. Okay, all right. So most of the conversions between grams, moles, and molecules involves this information. Okay, so if you want to go from moles to grams, you have to use the molar mass. If you want to go from moles to number of particles, these two are connected by Avogadro's number. So that's what it's helpful to put this in the form of a picture. So if you want to go from grams to moles, convert using the molar mass. Molar mass, it connects mass and mole. Okay, and if you want to convert moles to number of things, if you want to go ahead and count the atoms or molecules, use Avogadro's number. Okay, this is the bridge to go from moles and to the count of particles. Okay, let's see some sample problems now. Also, one more thing I want to point out. Let's say you're given moles of water and they're asking you how many moles of hydrogen atoms are there. Okay, so the substance water and hydrogen in the water are connected by the molar ratio 1 to 2. For every 1 mole of water, you have 2 moles of hydrogen. Okay, so that's the connecting factor between water and hydrogen, hydrogen in water. Okay, or you could also say 1 molecule of water. So imagine 1 molecule of water. Count the hydrogens. It contains 2 hydrogens, okay? 2 hydrogen atoms. That's another connection between water and the hydrogens in it, okay? These are some helpful conversions which will help you navigate through some problems that I'm going to discuss. Okay, here's our first problem. So the question is, how many formula units are in 5.7 moles of calcium nitrate? And what is its mass? That means what is the mass of this 5.7 moles of calcium nitrate in grams? We have two parts to this question. Let me label this as part A, this is part B. Don't forget the connection between moles, grams, and the things. So in this first part, we are looking for the connection between how many, that means number of things, and formula units just means molecules. So you can say, instead of calling it formula units, you can call molecules. Usually for ionic compounds, we use the term formula units, but understand them as same as molecules. So how many if you have 5.7 moles? So we are connecting moles with number of things. So we have to use the Avogadro number. So we can say if you have 5.7 moles of calcium nitrate, okay? Each mole of calcium nitrate, you have to use the Avogadro number to connect them. And moles should be on the bottom because you want to cancel those out. And number of things should be on the top. So 1 mole is how many? That's 6.022. So 6.022 times 10 to the 23. That many number of calcium nitrates. Okay, so you can take this off. So that many calcium nitrates. Okay, calcium nitrates. So you can calculate that, and the answer turns out to be 3.4 times 10 to the 24. Okay, that many calcium nitrate units, formula units. Okay, we have to round off to 2 decimals because we have 2 decimals here. Okay, think about it. What we just did is multiplying the Avogadro number by 5.7. 1 mole is 6.0233. So if you have 2 moles, it will be 2 times this number. If you have 5 moles, it will be 5.5 times this number. If you have 5.7 moles, it will be 5.7 times this number. This is what essentially we have done, okay? Next part B, we are connecting the mass in grams. We are asked what is the mass in grams for 5.7 moles. We are connecting mass with moles. They're connected by molar mass. So let's get the periodic table and calculate the molar mass of calcium nitrate. We should know the formula for calcium nitrate first. Calcium ion, calcium is in the second group of the periodic table. You can see calcium is in the second group here. Okay, so calcium is 2 plus. Nitrate, it's ending with 8, so it's one of the polyatomic ions you should have memorized. So it's actually NO3 negative. So when you do crisscross, when you do a crisscross, the formula for calcium nitrate is 1 calcium and 2 nitrates. So CaNO3 twice. That's the formula for calcium nitrate, okay? So we can calculate its molar mass. You have 1 calcium, so 1 times calcium's mass, molar mass. We have 2 nitrogens, okay? Remember, NO3 2 means you have 2 nitrates. So you have 2 nitrates. And that would mean 2 nitrogens. So this, the 2 that is outside should be multiplied with the 1 that is the subscript for nitrogen, okay? So 1 times 2. So you have 2 nitrogens, so 2 times the number below nitrogen. 6 oxygens, 3 times 2. So 6 times the number below oxygen. And add them all up, you should get 164.10. That's the molar mass of calcium nitrate. I'm going to go ahead and put that. Molar mass is 164.10 grams per mole. Okay, let me get rid of the periodic table and this one. Okay, there's no eraser in this presentation, so I have to use my pen to do that. Okay, anyway. So we have the molar mass. So let's start the problem. Start with what you're given. You're given 5.7 moles of calcium nitrate. You're going from moles to grams because we want to cancel out moles. We put that in the bottom. And we want to end up with grams. And the connection is 1 mole, this is per mole, so 1 mole weighs 164.10 grams. This is the weight of always 1 mole. You don't want to put this as 2 moles or 3 moles. No, 164.10 is always the weight of 1 mole of that substance, okay? And that is going to give me 935.37 grams. You can check my calculation, and I have to round this off to 2 decimals, so it's going to be 935. So we have to drop this number here. We need to keep only 2 sig figs, and since the number that I'm dropping is greater than 5, I have to round up, so it's going to be 940 grams, which has 2 significant figures. Okay, review this problem. I hope that makes sense. You want to make sure that you're canceling the units that are given and going to what you need. So let's do a few more problems. Here is example number 2. How many moles of glucose is 1 kilogram of glucose? That's our first part. I'm going to call it A, B, C, D. Okay, let's get our chart. What are we connecting? We are connecting moles with mass. Moles to mass is connected with molar mass, but you need your mass in grams. So first step, convert your kilograms to grams, and once you have grams, use the molar mass to go to moles to answer your question. So here's how you will work this out. Start with what you're given. So 1 kilogram glucose, and go from kilograms to grams, and we know that 1 kilogram has 1,000 grams. Okay, kilograms cancel out. Now we go from grams of glucose to moles of glucose to answer our question. So grams of glucose to moles of glucose. The connection is through molar mass. So let's get our periodic table and calculate the molar mass. So you need to do, glucose formula is C6H12O6. So you need to do 6 times carbon's weight plus 12 times hydrogen's weight plus 6 times oxygen's weight. If you go ahead and do that, you should get, please check this answer. I got 340, I'm sorry, I got 180.18 grams per mole. So that's the molar mass of glucose. So that means 1 mole of glucose should be 180.18. This weight of glucose is always the weight of 1 mole. In any problem, this is not going to change. This weight is always the weight of 1 mole, because by definition, molar mass is the weight of just 1 mole. Okay? 1 mole means Avogadro number, in other words. Okay, now our calculation will give us moles, and you should round your answer to 2 significant figures, and that would give you 5.6 moles. Please check my answer by working this out yourself. Okay, next problem. Problem B, we are asked for how many. How many means we are looking for a number of things. How many glucose molecules is that? So now that we have moles, we can go to number of things with Avogadro's number. And you can guess, 1 mole means Avogadro number of things. 2 moles means 2 times Avogadro number. So 5.6 moles means 5.6 times Avogadro number of glucose molecules. So you can show that also with the dimension analysis. So start from what you got. So 5.6 moles of glucose, and each mole, 1 mole glucose means 6.022 times 10 to the 23 glucose molecules. Okay, I'm writing this out, spelling this out for you, just so you don't get confused between mole and molecule. So moles cancel out, you get molecules. So that's going to be 3.3 rounded off to 2 sig figs will be 3.3 times 10 to the 24. That many glucose molecules. Okay, next let's do C. How many hydrogen atoms is that? So until this point we have number of glucose molecules. So imagine that many glucose molecules. So if I write, for example, if I write this 2 times, you have 2 glucose molecules. Okay, if I write these units 3 times, I'm representing 3 glucose molecules. Okay, so imagine that many, writing out that many glucose molecules. How many hydrogens are they going to contain? If I have 2, I'll have 2 times 12. If I have 3, I have 3 times 12, that many hydrogen atoms, because there are 12 in each. So if I have that many glucose molecules, there's going to be 12 times that many, okay, because there are 12 in each. So you can set this up with dimension analysis as your starting number will be 3.3 times 10 to the 24 glucose molecules. So instead of writing glucose, let me show you. Let me write C6 10 to the 24 C6H12O6 molecules, and that's what you have. And for every 1 molecule should be on the bottom because we want to cancel it out. So for every 1 molecule of C6H12O6, you're going to hydrogen atoms. So think about how it is linked. There are 12 hydrogen atoms in 1 molecule. Okay, so that's basically multiplying this number by 12. So that's going to give us 4.0 times 10 to the 25 hydrogen atoms. Okay, you could have done this by starting from here. Let's say starting from here, you're asked for hydrogen atoms. So you'd convert kilograms to grams of glucose to moles of glucose, then next moles of glucose to molecules of glucose, and then you're multiplying by 12 because there are 12 hydrogens in each molecule. Another way to do this is You can go from kilograms of glucose, kilograms of glucose, C6H12O6, to grams of glucose. So let's say you're starting from here. How many hydrogen atoms are in 1 kilogram of glucose? So you can do kilograms to grams. Next, grams of glucose to moles of glucose using the molar mass of glucose. And then you can go from moles of glucose to moles of hydrogen. That's another way to do the same problem, okay? And the ratio is 1 to 8. 1 mole of glucose has, 1 to 12. So 1 mole of glucose has 12 moles of carbon, okay? So you could go from moles of glucose to moles of hydrogen. I kept saying carbon, I meant hydrogen. And then once you have moles of hydrogen, you can convert them to molecules. Molecules of hydrogen. I shouldn't say molecules when I have just hydrogens. Those would be atoms. Moles of hydrogen to atoms of hydrogen, okay? Using the Avogadro's number. You can go from moles, if you have that many moles, how many atoms is that? You can find that using the Avogadro number. That's another way to do the problem if starting from kilograms, okay? All right, next we are going to look at D. What is the mass of 1 molecule of glucose? So let me make some space here. Remember, the molar mass that we calculated was 180.18 grams per mole. Okay. All right, this time what are we connecting? What is the mass? I'm looking for mass. Let's say it's asking in grams. For 1 molecule, so I'm told how many, the count of molecules, and it's 1, okay? So starting with one thing, 1 molecule, I'm asking you what's the weight of it. So you have to convert this to moles first, and then moles to grams. So let's do this step by step. We are working on the last part. So you have 1 molecule, 1 tiny molecule, just 1 of this, C6H12O6, okay? Now go from molecules to moles. Molecules of C6H12 to moles of C6H12O6. And the relationship is 1 mole has 6.022 times 10 to the 23 molecules. Mole is a big unit, okay? Big number, lots of things. So 1 mole should have lots of molecules. 1 mole of these means that many, okay? All right, you cancel out molecules. And now think about where I need to go. I need to have moles of C6H12O6 on the bottom because I want to cancel these. And you can go from grams from there, okay? You can go to grams from there. Grams of C6H12O6. And the relationship is through molar mass. 1 mole weighs that much. So 1 mole weighs 180.18 grams. Okay, and that calculation is going to give you 3.0 times 10 to the negative 22 grams. And you can write it as 3.0 times 10 to the negative 22 grams per molecule. This is the weight for 1 molecule. So you could have written out the unit like this as well, okay? Write example number Example number 3. I want you to read this and set up the problem and then come back and check your answer. Okay, let's work this out. The main component of gasoline is octane. The formula is given to you. Assume that the gasoline is made entirely out of octane. How many atoms of carbon are there in 2 milliliters of gasoline? Okay, so you're looking for the count of atoms. So let's get our chart. You're looking for number of carbon atoms. okay? You have to convert the substance. Remember, you're given the amount of gasoline. Now we are looking for carbon, okay? So you have to use the molar relationship between gasoline and carbon. That's 1 to 8. So how do we do this? We are looking for, you have 2 milliliters of C8H18, and you are looking for the number of carbon atoms. So one way to do this is, first you're looking for a number, so you have to go via grams, okay? And to get grams from volume, you have to use density. Remember, volume and density conversions. Remember, volume and density are connected. Remember, volume and mass are always connected by density. So we are going to use the density to change milliliters to grams. So these two are connected. Grams of C8H18. And then once you have grams of C8H18, you're going to turn that into moles using the molar mass. Moles of C8H18. And then once you have moles, you can solve this different way. One of the ways is go from moles of C8H18 to moles of carbon. The ratio is 1 to 8. For every 1 mole, one of this, you have 8 carbons, okay? And then once you have moles of carbon, change it to number of carbon using the Avogadro number. Another way is you can change moles of C8H18 to number of molecules of C8H18 using the Avogadro's number. You can go from moles to number of those. And then once you have molecules of C8H18, you can go to number of carbon atoms, again using the 1 to 8 ratio. One molecule of this has 8 carbon atoms. So I'm going to choose this method and work the problem out. So the setup will look like this. 2 milliliter octane to grams of octane. 1 milliliter weighs that much. So 1 mil is 0.755 grams. Milliliters cancel out. Next, go from grams of octane to moles using the molar mass. And if you calculate the molar mass of octane, I got it to be 114.23 grams per mole. So grams to moles of octane, 1 mole weighs 114.23. We used the molar mass. So grams cancel out. Next step, I'm going to go from moles of octane to moles of carbon, okay? And the ratio is 1 mole of these will contain 8 moles of carbon, okay? So now the moles of octane cancel out. Next, we go from moles of carbon to number of carbon atoms. So 1 mole of anything is Avogadro number. So 1 mole of carbon means Avogadro number of carbon atoms. Okay, so cancel the moles of carbon, and you're going to end up with 6.4 times 10 to the 23 carbon atoms. Please check my work. Make sure you're getting the same answer. All right, so as you can see here, basically what we have done is connected a bunch of units. This essentially boils down to a unit conversion problem, and you should know these conversion factors, okay? Practice is going to help you navigate through mole concept. And if you have any questions, I'm available during my office hours Wednesday to Thursday. And also SI is available on Tuesdays and Thursdays. Please check the timetable on the syllabus, and the web link, the online link, is also provided on the syllabus, okay? All right, everyone, you all have a great day, and please let me know if you have questions.